Distribution systems are becoming more complex, and with the addition of distributed energy resources, voltage regulator control is a lot more complex than it used to be. But with Flex DG mode in the SEL 2431 voltage regulator control, SEL simplified and future-proofed the control solution. Let's take a look. Traditionally, power always flowed from bulk generation to the end of the line. With the power source behind the voltage regulator, it only needed to regulate the circuit in a single direction, forward, away from the substation. Looped systems use intertie points to connect distribution circuits and restore power if there's a fault. But now, the power source could be behind or in front of the voltage regulator. This is important because a voltage regulator can't change the voltage in the part of the circuit that sits between it and a substation that delivers bulk power. For our purposes, we'll call these traditional substation sources stiff sources. If we attempt to increase voltage on the side that has a stiff power source, we achieve nothing. And on the other side, we actually reduce voltage. One common solution is a bidirectional mode that measures power flow. When the voltage regulator control detects a reverse power flow, it switches direction so that it's correcting the voltage downstream from the new power source. Now let's say a DER site has been added to our simple system. With a weak source in the circuit, the direction of power flow no longer depends entirely on the stiff utility source. Now that power flow has been decoupled from the regulation direction, our voltage regulator control needs to ignore the direction of flow to ensure that it continues to regulate downstream from the stiff power source behind it. But in a looped circuit with DERs, we have a new challenge. Power can flow in either direction, and the source of a reverse flow could be either a stiff source or a nearby DER site, which means both of the modes we've seen so far could leave us trying to regulate voltage in the wrong direction. Here's how Flex DG mode in the SEL 2431 voltage regulator control solves that problem. We start in the usual way, regulating voltage downstream from the stiff source by default. Meanwhile, the Flex DG algorithm measures the effectiveness of every tap. If voltage doesn't change as expected, the control switches regulation direction and evaluates the effectiveness of subsequent taps. Here, we see a reverse direction power flow. The Flex DG algorithm verifies that voltage regulation is working properly, so the control keeps the regulator tapping in its original direction. Now, power is flowing in a reverse direction again. But this time, Flex DG measurements show that the voltage regulator is having no effect. The power on that side must be coming from a stiff source. The control now switches direction, tapping the regulator to control the voltage in the proper direction, downstream from the stiff source. Using this method to detect stiff sources, Flex DG in the SEL 2431 can always find the correct direction to regulate voltage. And it's future-proof. No matter how many DERs are added in your system or where they're located, it still works.